Global shipping is pretty much the backbone of our world economy, but it has a huge problem. Today, we're going to dive into a breakthrough technology that promises to completely transform this colossal industry, making it cleaner and cheaper. Not in 30 years, but like right now. Let's get into it. Okay, so to get a sense of just how big this challenge is, think about this. Right now, there are about 50,000 of these massive commercial ships sailing our oceans. I mean, think about that. That's 50,000 engines, many of them the size of a small house, just constantly burning fuel.
And all that fuel, well, that's where you find the industry's big, dirty, and very expensive secret. For decades, it's just been this trade-off between keeping the economy moving and the environmental damage. But that whole era, it's coming to an end.
So what you have here is a real perfect storm for the shipping industry. You've got fuel prices just shooting through the roof. Then there are the emissions. We're talking CO2, nitrogen oxides, all that nasty particulate stuff. And regulators are watching like a hawk. All of this is happening while the basic costs to just operate and maintain these ships keep going up and up. And look, this isn't just some friendly suggestion. We're talking about hard and fast rules. The International Maritime Organization, the IMO, has put some serious deadlines in place. So by 2030, they need to slash carbon intensity by at least 40%. By 2050, cut total greenhouse gas emissions by half. The message to ship owners is pretty simple, right? Change, or you're going to get left behind. Okay, so we've laid out this huge, urgent problem. What's the fix? Well, let's look at a solution that honestly sounds almost too simple to be true. And it starts with something they have an endless supply of right under the keel. And right here, this is the big aha moment. I mean, what if you could just skip the whole multi-billion-dollar global hydrogen refueling network? What if you could just, make your own fuel right there on the ship using nothing but seawater? That's the absolute genius of the H2DT system. It doesn't just solve the hydrogen infrastructure problem, it makes it completely irrelevant. So how in the world do you actually turn seawater into power? Well, the beauty of it is just how simple it is. Let's break down how this thing actually works when it's on a vessel. It's this really elegant, totally self-contained three-step process. Okay, first, you've got an electrolyzer right on the ship. It takes a little of the ship's power and uses it to split seawater into hydrogen and oxygen. Simple enough. Then, and this is the clever part, that hydrogen gets safely soaked up and stored in a special solid material. And finally, a super precise dose of that hydrogen gets injected straight into the existing diesel engine, which makes every single drop of fuel burn way cleaner and more efficiently. Okay, this storage part is really cool. Because, when most of us hear hydrogen, our minds jump to these high-pressure tanks, right? The kind that could be dangerous. But that is not what's happening here. This metal hydride stuff is more like a high-tech metal sponge. It literally soaks up the hydrogen at low pressure, bonding with it chemically, and it only lets it go when you ask for it. It's just inherently safe. And this really drives the point home. Just look at the difference. On one hand, you have the old way, high-pressure gas or super cold liquid hydrogen. Both are risky, both are expensive. And then you've got the H2DT way. Low pressure, chemically stable, super compact, and, get this, completely autonomous. You don't need any help from the shore. For a ship out at sea, that is a total game changer. All right, so it's safer, it's way more practical, but what about the money? Does it actually make sense financially? Well, this is where the story gets really interesting. Because the payoff here isn't just about being green. It's about saving a ton of green. So, the one-time cost to get one of these systems on a single ship is about 1.35 million euros. And yeah, I know what you're thinking. That is a lot of money. It is. But just hang on to that number for a second. Because for that exact same ship, the potential savings on fuel every single year can be up to $1.35 million. All of a sudden, that big upfront cost doesn't seem so big anymore, does it? I mean, we're literally talking about a system that pays for itself just with the fuel it saves. So yeah, it all comes down to that payback period, right? And get this, the projections show a full return on that investment in as little as 2.5 years. And after that, every penny you save on fuel, plus savings on maintenance, which can be up to 30% by the way, that's all pure profit, straight to the bottom line. And here's the kicker. While you're saving all that cash, you're also doing this. Just look at these numbers. A CO2 reduction of up to 80%, plus huge cuts in NOx and all that other nasty stuff.
This doesn't just meet those crazy strict IMO regulations we were talking about earlier, it absolutely smashes them. Okay, but let's be real. This solution isn't the only game in town. There are other green technologies out there trying to clean up shipping. So you have to ask, why is this one the winner? What gives it such a huge edge?
All right, this slide right here is basically the mic drop. Just look at this. H₂DT retrofit versus everything else. The upfront cost, $1.35 million, versus what, $15 to $25 million for a new battery ship? No contest. Payback is 2.5 years versus maybe 5 to 10 years if you're lucky. But that third row, port infrastructure, that's the killer. H₂DT needs little to none. Every single other option needs massive, ridiculously expensive new projects at ports all over the world.
So let's just boil it down. What's the unbeatable edge here? It's a fast and pretty low-cost retrofit for the ships that are already out there. You don't have to build a whole new fleet. It bolts onto the diesel engines they already have, gives them a proven, fast ROI, and, this is huge, it does it all without needing a single new port mega project. It's a solution for the world we actually live in, not some fantasy future.
So when you got a solution that is this practical for a problem that is this big, well, the numbers are about to get absolutely staggering. We are talking about a market opportunity that is just massive.
Okay, remember those 50,000 ships we talked about at the beginning? Well, the analysis shows that about half of them, a whopping 25,000 vessels, are perfect candidates for this exact retrofit. That is just an enormous market waiting to happen.
And if you do the math on that, you're looking at a total addressable market somewhere in the neighborhood of 30 billion euros. This isn't some tiny niche product, you see. This is a foundational technology for a whole global industry. You know, in the end, you can really boil the entire pitch down to this one powerful statement. It's a fast, low-cost retrofit that slashes fuel and CO2 with a payback of about a year or two, not a decade, and it does it with no need for new port mega projects and with barely any downtime. I mean, how do you argue with that? So all of this, it really leads to one final, pretty provocative question, doesn't it? We're always talking about clean tech for the future, right? Things that are decades away, that'll cost trillions of dollars to build out. But when you have a solution right here, right now, that's cheaper, that's safer, that's faster to roll out, and that works with the stuff we already have, it really makes you wonder, maybe the future of green shipping isn't something we have to wait for. Maybe it's already here, just waiting to be installed.